The stability of a modern city is an illusion. We see concrete, steel, and glass as permanent fixtures, assuming the invisible systems that give them life are just as constant. But they are not fixed. They only appear that way. The intricate web of energy, data, and logistics that underpins urban existence is in a perpetual state of flux, constantly adapting to prevent collapse. Introduce a powerful enough change, a new source of seemingly limitless power like nuclear fusion, and the entire structure doesn't break. It quietly and irrevocably realigns. This deep reset begins by altering three core pillars of urban life. The first to change is the economic foundation, as the very concept of energy scarcity begins to dissolve. Next, the physical environment of the city itself starts to morph, with air quality, ambient temperature, and noise levels shifting. Finally, the social fabric is rewoven as patterns of work, housing, and movement are forced to adapt to a new reality defined not by limitation, but by an unprecedented abundance of power. The transformation is not a distant, futuristic dream unfolding over centuries of slow progress. It is a compressed event, a matter of mere decades. The old world, built on the logic of finite fossil fuels, gives way with startling speed. The initial effects of this fusion-powered reality are subtle. A change in the nighttime sky's glow. The intermediate consequences become more pronounced. By the end, the world still functions, but the underlying operating system of civilization has been rewritten. Before the quiet reset, our subject city is a sprawling, familiar organism. Let's call it Ethelberg. Its lifeblood is a conventional energy grid, natural gas power plants, aging nuclear fission stations, and a patchwork of solar and wind farms. This city operates in a constant state of managed scarcity, a delicate balancing act to prevent blackouts. The air in pre-fusion Ethelberg carries a distinct chemical signature, a visible reminder of the millions of internal combustion engines. At its core, a fusion reactor is a magnetic containment device, a sophisticated chamber known as a tokamak. Deuterium can be extracted from ordinary seawater. The primary byproduct is helium. This process generates no greenhouse gases and no high-level long-term nuclear waste. The energy density is staggering. The fuel required to run such a plant for an entire year would weigh less than a small car. Before the reset, this technology was the stuff of laboratories and immense international collaborations like the ITER project. The city's baseline energy demand sits at around 8 gigawatts. During peak hours on a hot summer afternoon, demand can surge to over 25 gigawatts. Daily life is unconsciously choreographed by this continuous flow of electricity. The entire rhythm of urban life is dictated by the availability and cost of a kilowatt hour. A power outage lasting more than a few hours is not an inconvenience, it is a systemic crisis. The first tangible consequence is not a dramatic event, but a subtle sensory change. As the first fusion plant comes online, it starts feeding immense, unwavering power into the grid. In the quiet of night, a new sound appears. The sound of a system under unprecedented, yet stable pressure. The small anxieties that governed energy use evaporate. People stop checking the time before running the dishwasher. The flickering and brownouts that once plagued outlying districts become a distant memory. The second major consequence manifests as a change in the city's microclimate. This widespread, aggressive cooling starts to subtly counteract the heat island effect. This new thermal reality is powered by water. As cooling becomes ubiquitous, Ethelberg's water consumption skyrockets. The brine discharge from the desalination plants alters the local marine ecosystem. The third immediate consequence occurs on the streets. The Great Unplugging is not a gentle transition. It is an aggressive, top-down overhaul. The first to go are the diesel buses. The city's port is retrofitted. A vast network of fast charging stations is installed. Gas stations, once ubiquitous corner fixtures, become obsolete. Many are demolished and redeveloped into parks. The fusion-driven collapse of tiered electricity pricing eliminates the economic incentive for running energy-intensive industries only at night. The city becomes a place that never truly sleeps, creating a perpetual, low-grade hum of human and economic activity. Family life is disrupted as parents work asynchronous hours. A significant portion of its population is forced to adapt to a new artificial rhythm of life. The system-wide impact begins in two seemingly unrelated sectors: data and agriculture. This triggers a data bloom. In post-fusion Ethelberg, vertical farming becomes the dominant form of agriculture. Automated facilities, powered by the fusion grid, grow fresh produce year-round. The consequences for regional food supply chains are immediate and severe. Rural farming communities are devastated. The city develops a new form of economic gravity, pulling heavy industry back from overseas. This process, known as reshoring, happens with astonishing speed. These are not the dirty, labor-intensive factories of the past. They are clean, hyper-efficient facilities. The city government is forced to initiate massive citywide reskilling programs, attempting to retrain hundreds of thousands of workers. Ethelberg becomes a closed loop, an island of near-total self-sufficiency, incredibly robust against external shocks. The most profound long-term impact is the Great Inversion, a complete reversal of the city's real estate and demographic patterns. Developers begin converting empty office towers into luxury residential buildings and vertical recreation spaces. The sprawling suburbs of the 20th century become the least desirable places to live. They fall into neglect. The single downtown dissolves, replaced by a polycentric city with multiple nodes of intense activity. The quiet reset is complete. Ethelberg has reached a new stable equilibrium, a state fundamentally altered yet fully functional. This new stability is not a utopia. It is a trade-off. Social structures have been reconfigured, creating new forms of inequality. The city functions with the precision of a circuit board, its human components integrated into a seamless, hyper-efficient system. Ethelberg is not a failed state or a grim dystopia. It is something far more complex, a successful, stable, and deeply altered world. What happens if this model is replicated across the globe? A planet of self-sufficient city-states? The next great technological leap will trigger similar cascades. Our systems are more fragile and interconnected than they appear. For every problem we solve, we create a new problem at the next level of complexity, a horizon that keeps receding. What scenario should we explore next? Share your ideas below. You've been watching IfVerse, where imagination meets possibility. See you in our next reality.